The morning of June 15, 1943, dawned clear and cold, 25,000 feet above the English Channel. German pilot Klaus Brenner sat wedged in his Messerschmitt's narrow cockpit, squinting through the canopy at the American formation bearing down on him. 8 P-47s approached, those ungainly, bulbous fuselaged thunderbolts. For months, the Luftwaffe had been swatting them from European skies like oversized flying nuisances. Brenner felt confidence surge through him. The thunderbolts climbed at a pathetic rate, barely 1,500 feet per minute, while his 109 could pirouette around them in a vertical engagement. His plane danced where theirs lumbered. This would be easy. But something went terribly wrong the moment Brenner pitched into his attack dive. The lead thunderbolt didn't flee. It didn't bank away. Instead, the massive aircraft reared up into a climb so violent, so aggressive, that it shattered everything Luftwaffe intelligence had taught him about American fighters. The P-47 clawed upward at nearly 2,000 feet per minute, its engine roaring at absolute maximum. It came charging straight into Brenner's own territory. Inside his cramped cockpit, the German pilot felt something unfamiliar. Genuine fear. That enormous 13-foot propeller, spinning with revolutionary blade engineering, had transformed the sky's biggest joke into its most lethal hunter. Back across the Atlantic, the reality of combat painted a bleak picture that no Pentagon optimism could hide. By September 1943, the P-47 had become infamous among American pilots. Experienced men were requesting transfers to any other aircraft that could fly. Even the Luftwaffe's cruel nickname for it, the Jug, after its milk bottle shape, had crossed enemy lines and now haunted Allied briefing rooms with bitter irony. At Wright Field, Colonel James Johnson sat reviewing combat assessment reports. His coffee had gone cold as he studied the numbers, each one worse than the last. The P-47 couldn't climb worth anything, only 1,500 feet per minute, while Messerschmitt 109s ascended at better than 3,000 feet per minute. Over occupied France, German pilots had discovered a devastating tactic: climb above the American fighters and then pick them apart at leisure. The American fighter was massive, over 7 tons fully loaded, and that weight trapped it in the lower sky. It simply couldn't follow enemy aircraft where modern combat was decided. Frank Caldwell, an engineer at Hamilton Standard Division, studied those same reports from his cramped office. Where military commanders saw catastrophic failure, Caldwell saw a physics problem waiting to be solved. The Pratt & Whitney R2800 engine buried in the P-47's nose was extraordinary. It produced 2,300 horsepower, more raw power than any fighter engine anywhere in the world. Yet somehow all that tremendous energy was being wasted, lost to inefficiency. The engine wasn't the problem. The airframe wasn't the problem. The real culprit was the narrow propeller blade, just 11 feet across, that couldn't possibly grab all the power the engine wanted to deliver. Propeller design hadn't fundamentally changed since the First World War. Engineers built them with thin, knife-like blades that sliced efficiently through the air during cruise. But when combat demanded maximum power, all that cruise efficiency meant nothing. At full throttle, the P-47's propeller tips approached supersonic speeds. Shockwaves formed, lift disappeared. The propeller became an expensive air brake instead of a thrust generator. Caldwell's mind began working through a solution that violated every conventional rule of propeller engineering. Rather than building thin blades for cruise efficiency, he imagined something entirely different. Broad, paddle-shaped blades that could grab enormous quantities of air and hurl it backward with raw force. The design would resemble a boat propeller more than an aircraft prop. Thick, wide, almost crude-looking. It prioritized brute thrust over elegant efficiency. When Caldwell presented his idea to his colleagues at Hamilton Standard, they listened with polite doubt. Tom Richards, the division's senior aerodynamicist, outlined the obvious obstacles. The paddles would add significant weight. Drag during cruise would increase substantially. Manufacturing such a design would be hideously complex, almost impossible to produce in the quantities the military needed. The military had already spent millions on existing propeller equipment. Retooling production lines for something unproven would demand enormous spending and delay aircraft deliveries for months. but Caldwell had run the numbers carefully. A 13-foot diameter propeller with paddle blades could absorb the full 2,300 horsepower the R2800 could produce. More thrust would overcome the added drag. The larger diameter would reduce tip speeds, killing the shockwave problem that plagued current designs. Most importantly, it could transform the P-47's terrible climb performance into something that could actually challenge German fighters. Hamilton's standard skeptics weren't alone. At Curtiss Electric, their chief rival in military propeller manufacturing, senior engineer Robert Hayes dismissed the paddle blade approach as a desperate gamble on an unfixable airplane. Curtiss was developing their own solution, a refined, narrow blade design with improved pitch control and slightly larger diameter. Their method was conservative. Proven, it used existing manufacturing equipment. The Army Air Forces faced a fork in the road. The conservative path offered small improvements with minimal risk and cost. The radical path promised dramatic performance gains, but carried substantial technical and financial dangers. Colonel Johnson had to choose between them, knowing that thousands of American pilots heading into European combat would live or die based on his decision. Meanwhile, German intelligence officers tracked American aircraft development with meticulous precision. Major Wilhelm Specht, stationed at a Luftwaffe Technical Evaluation Center in occupied France, had personally examined several captured P-47s. His reports to Berlin carried dismissive certainty. The American fighter was brute force design, relying on heavy armor and powerful engines to compensate for poor aerodynamics. German pilots could exploit its sluggish climb and poor handling indefinitely. This confidence rippled through the entire Luftwaffe command structure. The Americans could build aircraft quickly and in astronomical numbers, but they seemed incapable of matching German engineering excellence. The P-47 represented everything inferior about American design. Big, heavy, crude, inefficient. Luftwaffe pilots joked that shooting down a Thunderbolt was like hunting a flying refrigerator. Hard to miss. Certain to drop once hit, September's test flights at Wright Field would answer the fundamental question: which philosophy would equip American fighters for the brutal battles ahead? Caldwell's paddle blade propeller had been installed on a single P-47D for evaluation. The aircraft looked almost comical sitting on the flight line. Its massive propeller blades appeared designed for cargo planes, not fighters. Test pilot Captain Robert Anderson climbed into the cockpit with direct orders to push hard and report everything he found. As Anderson taxied toward the runway, neither he nor the engineers watching could imagine they were about to witness something extraordinary: the transformation of American aviation's biggest disappointment into its most feared weapon. Years of conventional fighter design wisdom would shatter against 13 feet of revolutionary engineering that would remake air combat over Europe. The first test flight on October 12th lasted exactly 14 minutes. Captain Anderson brought the modified P-47 back to the field, reporting a disturbing vibration running through the entire aircraft. The massive paddle blades had created harmonic oscillations that threatened to shake the plane apart above 70% throttle. Frank Caldwell watched from the control tower as ground crews swarmed the aircraft, searching for stress fractures and loose rivets. Propeller vibration had haunted aviation since the Wright brothers, but this intensity suggested fundamental design flaws. Caldwell's team spent 3 weeks completely redesigning the blade attachment system and rebalancing the propeller hub. The original blades had been manufactured using standard techniques perfect for narrow designs, but catastrophically inadequate for the massive forces generated by paddle blades. Each blade weighed twice what conventional designs weighed, creating rotational stresses the standard hub couldn't manage. The solution demanded custom-forged blade shanks and a completely redesigned hub assembly that added 200 pounds to the aircraft's nose section. The second test flight on November 5th brought different but equally disappointing results. The vibration was gone, but the new propeller's performance fell far short of Caldwell's calculations. Instead of the projected climb rate improvement to 1,900 feet per minute, Anderson reported barely 1,600 feet per minute, just 100 feet per minute better than standard. Top speed barely improved, reaching 410 miles per hour instead of the baseline 400. Robert Hayes at Curtiss Electric received these disappointing results with barely suppressed satisfaction. His team's refined narrow blade design had completed its own testing the previous week with much more encouraging numbers. The Curtiss propeller achieved 1,750 feet per minute climb and maintained the aircraft's existing speed without paddle blade weight or manufacturing difficulties. Hayes sent his results to Colonel Johnson with a note suggesting that Hamilton Standard's radical approach had proven itself an expensive mistake. But Caldwell saw something different. The problem wasn't the paddle blade concept itself. It was blade angle optimization and pitch settings. Initial design had relied on theoretical calculations assuming perfect conditions. Real-world testing revealed the optimal blade angle for climb differed significantly from the angle producing maximum level flight speed. The P-47's constant speed propeller adjusted pitch automatically during flight, but adjustment range had been calibrated for narrow blade designs. Working 18-hour days in Hamilton's engineering labs, Caldwell's team developed a new constant speed mechanism with twice the pitch adjustment range. The modification required substantial changes to the propeller governor and hydraulic system, but it would let paddle blades operate at optimal angles throughout the entire flight range. The system could shift from coarse pitch for high-speed flight to extremely fine pitch for maximum static thrust during takeoff and climb. The engineering required went beyond pitch control alone. The paddle blades created a bigger target for the air passing through, but this advantage came with a serious problem. More air was being pulled into the engine cooling system, yet it moved too slowly because of the extra drag. The R2800 engine, with its 18 cylinders, began overheating when pilots pushed the aircraft hard for extended periods. Caldwell and his engineers faced a critical challenge. They had to completely rework how air flowed through the engine compartment and install more cooling vents along the fuselage. Meanwhile, Lieutenant Colonel Johnson was catching heat from the Pentagon brass, who weren't convinced the P-47 program was worth the money anymore. The new P-51 Mustang was looking incredibly promising in its early tests, delivering performance that made even the modified Thunderbolt look slow by comparison. Some decision-makers wanted to drop the Thunderbolt work entirely and put all those resources into building more Mustangs instead. Then came December 8th, and the third test flight that changed everything. Anderson took the redesigned P-47 up with the new pitch control system and improved cooling, and he pushed that machine through maneuvers that would have torn apart any standard Thunderbolt. The aircraft climbed from sea level to 20,000 feet in just 10 minutes and 40 seconds, reaching 1,080 feet per minute, which put it right in the neighborhood of German fighter performance. What really mattered was that the Thunderbolt maintained this incredible climb rate while carrying everything a combat pilot would need: armor plating, ammunition, full fuel tanks. The speed results were just as impressive. Up at 25,000 feet, the modified P-47 hit 445 miles per hour in level flight, a full 45 miles per hour faster than the standard version. The improvement didn't come from less air resistance, but from the paddle blade's superior ability to squeeze more thrust from the same powerful engine. In the thin air at high altitude, those broader blades had a real bite, providing advantages that traditional propellers couldn't match. Most shocking of all were the dive recovery tests. For years, the P-47 had earned a reputation as a stubborn creature when pilots tried to pull out of steep, high-speed dives. The standard propeller simply couldn't generate enough backward thrust to overcome the aircraft's enormous weight and momentum and slow it down. Anderson discovered something remarkable. When he switched the paddle blade to fine pitch, it created reverse thrust powerful enough to help the aircraft decelerate and escape from dives that would have been fatal with the original setup. German observers watching from afar saw this as a curiosity rather than a threat. Luftwaffe intelligence analysts shrugged off the larger propeller as just another desperate American attempt to salvage an outdated fighter. Their assessment concluded that even with the propeller upgrade, the P-47 was still outclassed by German fighters, except in pure speed and diving capability. Those December trials gave Colonel Johnson the confidence to move forward. He authorized small-scale production of the paddle blade propeller, and Hamilton Standard won a contract to build 50 units for installation on P-47D-22 aircraft, heading to Europe in early 1944. It was a gamble with American pilots' lives on the line if something went wrong in actual combat. Caldwell's team worked straight through the Christmas break, setting up the manufacturing machinery and training workers on the new production methods. Each paddle blade propeller took 40% longer to manufacture than standard designs and cost nearly twice as much. The expense was staggering, but transforming the P-47 into a real fighter made the risk worth taking. When 1944 arrived, the first production paddle blade propellers started rolling out of Hamilton Standard's factory, heading for modification centers where they'd be bolted onto Thunderbolts destined for combat in Europe. Nobody, not the American engineers who created them, not the German pilots about to meet them in the sky, could have predicted how completely these 13 feet of revolutionary metalwork would reshape the entire air war over occupied Europe. The first batch of paddle blade P-47s touched down at RAF Boxted on March 15, 1944, and immediately caused problems. Captain Mike Gladych, a Polish-born fighter pilot with 12 confirmed kills, took one look at those enormous propeller blades and wasn't happy about what he saw. Compared to the slim, elegant propellers he'd always flown with, these looked crude and oversized. Other pilots started calling the new birds barn door specials and asked their commander if they could keep flying their old Thunderbolts until the new design proved itself in combat. Colonel Harold Rao, the group commander, was in a tight spot. These pilots had survived months of vicious air combat by knowing exactly what their machines could and couldn't do. Making them switch to unfamiliar equipment could get them killed, but his orders from the 8th Air Force were crystal clear. Evaluate these modified P-47s in real combat conditions right away. The real test would happen not in safe training flights, but in deadly dogfights with experienced Luftwaffe pilots over enemy territory. That test came on March 22nd during a mission to escort B-17 bombers heading toward Berlin. Gladych led 4 paddle-blade Thunderbolts at 30,000 feet, providing top cover for the B-17 formation below. Then he spotted them. Then, a group of Messerschmitt 109s descending from 35,000 feet, setting up a classic diving attack. Normally, P-47s in that position would have no choice but to dive away, relying on their superior speed in a dive to escape the German fighters' climbing advantage. Gladych did something different. He pulled his 4 aircraft up into a steep climb to meet the attacking Messerschmitts head-on. Those paddle blade propellers grabbed the thin air with astonishing power, keeping the P-47s climbing at 1,700 feet per minute even at 30,000 feet, where standard propellers would have struggled to manage half that. The German pilots, expecting the American fighters to run, suddenly found themselves facing P-47s climbing directly at them, with enough energy to fight it out in the turns. The whole thing lasted barely 3 minutes, but it shattered 2 years' worth of German assumptions about American fighter capabilities. Gladych's wingman, Lieutenant Robert Johnson, managed to stay with a 109 through climbing turns that should have been impossible with the standard propeller setup. Major Hans Dormann, the Messerschmitt pilot, later reported to German intelligence that the American fighter had climb performance equal to their own aircraft, a claim his superiors initially wrote off as combat stress or pilot error. News of the engagement spread like wildfire through German fighter squadrons in western France. For years, German pilots had won fights by outclimbing American opponents and forcing them to accept battle on German terms from above. The idea that P-47s might now be competitive at high altitude threatened to overturn everything German pilots thought they knew about how to fight Americans. Group commanders sent urgent requests to intelligence asking for confirmation that American fighters had been modified. When Major Wilhelm Specht's Technical Intelligence Unit captured the first paddle-blade P-47 on April the 2nd, they got their answer. A pilot named Charles Morrison had taken damage from anti-aircraft fire during a ground attack mission and was forced to crash land near Calais. Morrison managed to wreck most of the sensitive equipment before being taken prisoner, but the propeller stayed intact. Specht's first report dismissed the paddle blades as oversized and predicted the modification would cause more trouble than it was worth. His deeper technical analysis told a very different story. German engineers examining the captured propeller realized they were looking at advanced metallurgy and precision manufacturing that exceeded anything the Luftwaffe was currently producing. The constant speed mechanism showed hydraulic control innovations that German designers hadn't figured out yet. What really disturbed them was the realization that Americans had cracked problems in propeller efficiency that German engineers had thought were impossible to solve with existing technology. Combat reports from April and May painted an increasingly dark picture. American P-47s were fighting German aircraft in climbing dogfights and winning. The 356th Fighter Group alone destroyed 21 German aircraft during April, mostly in engagements where standard P-47s would never have survived. German pilot losses climbed as the altitude advantage that had been the foundation of their tactics simply vanished. Everything changed operationally too. German fighter controllers had always positioned their aircraft to pounce on American bomber formations from above, confident that escorting P-47s couldn't climb fast enough to interfere. With the paddle blade propellers, American fighters could stay at bomber altitude and respond instantly to German attacks from any direction. German missions designed to shoot down bombers by attacking from above now faced determined opposition from American escorts operating at full strength. By mid-May, nearly every operational P-47 in Europe had been fitted with paddle blade propellers. Hamilton Standard was cranking out 200 units every month from their Connecticut factory, with Caldwell's engineers working shoulder to shoulder with production staff to improve manufacturing efficiency and fix quality issues. The numbers told the story perfectly by month's end. P-47 units flying the new propellers reported 40% more victories in air-to-air combat compared to their own performance with standard propellers. Even better, losses had dropped by 30% because pilots could now climb away from dangerous situations instead of only having their diving speed to rely on for escape. German fighter pilots stopped wanting to tangle with Thunderbolts. Colonel Johnson got the green light in late May to roll out the paddle blade modification to every P-47 variant being built. The European success convinced Pentagon planners that Caldwell's propeller represented one of the war's biggest technological achievements. New orders went out to retrofit existing Thunderbolts in the Pacific and to install paddle blade propellers on every new aircraft coming off assembly lines. German intelligence officers had a hard time explaining to their commanders how American fighter performance had jumped so dramatically. Major Specht's updated reports admitted the Americans had gained a significant technical edge, but the Luftwaffe lacked the industrial capacity and materials to develop anything comparable. German fighters would have to finish the war knowing they no longer had the superior climb and altitude advantage they'd relied on for years. The revolution was complete. Caldwell's paddle blade propeller had transformed the P-47 from the Luftwaffe's favorite prey into their most feared opponent, completely rewiring the tactics of air combat over Europe just months before D-Day would demand absolute Allied command of the skies. When D-Day dawn broke on June 6, 1944, nearly 400 paddle blade-equipped P-47s thundered across the English Channel as the sun rose. This enormous air fleet, tasked with guaranteeing Allied air superiority over the Normandy beaches, carried more modified Thunderbolts than any operation before it. Their broad propeller blades gleamed in the first light of what would become the longest day in aviation history. Colonel Francis Gabreski wheeled his 56th Fighter Group out over Omaha Beach just as dawn broke on that historic morning. 16 P-47 Thunderbolts climbed steadily upward, their engines roaring with a power that seemed almost miraculous compared to what these same aircraft had been capable of mere months before. Below them, the greatest amphibious assault ever attempted was beginning to unfold. Landing craft churned through the Channel waters, heading toward the heavily defended French shoreline where German guns waited. What struck everyone above was the absence of enemy fighters. The Luftwaffe simply wasn't there. The skies that German pilots had once ruled with absolute confidence now belonged entirely to the Americans. Oberst Adolf Galland, commanding the Reich's fighter forces, faced an impossible tactical situation. German fighters could no longer climb above American escorts to pounce on bombers from above. That strategy, which had worked so brilliantly in earlier years, had become completely obsolete. The new American propellers had changed everything. German pilots now found themselves forced to fight at lower altitudes, where the Thunderbolt's superior firepower and armor protection gave American pilots decisive advantages. Major Klaus Mietuscher received orders to intercept enemy fighter bombers threatening German positions near Caen. His Focke-Wulf 190s had once been able to outclimb any American fighter and dictate the terms of engagement. Those days were finished. The Thunderbolts now matched or exceeded the German fighters in climb performance, and they could sustain combat effectiveness at any altitude. As morning progressed, the first major air engagement developed when 24 Messerschmitt 109s attempted to strike at the Allied naval forces supporting the landings. Captain Robert Johnson's flight of 8 Thunderbolts, with the new propellers, intercepted them at 18,000 feet. Johnson's fighters had climbed from sea level in just over 8 minutes. The Germans never completed their attack runs. They were stopped cold before they could reach the vulnerable ships below. What happened that morning demonstrated how completely the propeller revolution had transformed air combat. German pilots trained to fight by climbing above their enemies found themselves utterly unable to escape American fighters that matched their climb rate while exceeding their horizontal speed. Lieutenant Hans Weich, flying his 43rd combat mission, reported back with shock in his voice. Those American Thunderbolts climbed like rockets. Pursuit through the maneuvers that would have easily shaken off standard P-47s only seemed to encourage them. By midday, Luftwaffe controllers received reports that staggered them. American fighters were operating at 30,000 feet and higher, altitudes that German aircraft designers had always assumed would be exclusively theirs. The Thunderbolts weren't just reaching these heights, they were fighting and winning dogfights up there through superior energy management. The new propellers allowed American pilots to trade altitude for speed and then regain that altitude quickly enough to maintain advantage throughout extended combat. The numbers told the story with brutal clarity. On June 6th alone, Allied air forces flew over 14,000 sorties, while the Luftwaffe managed fewer than 300. That wasn't just numerical superiority, it reflected the tactical dominance the new American fighters had established. German pilots who engaged Allied formations found themselves outmaneuvered by Thunderbolts that could climb, dive, and turn with an effectiveness that rendered traditional Luftwaffe tactics completely obsolete. General Adolf Galland's evening briefing painted a devastating picture for Hermann Göring. German pilots had claimed 17 Allied aircraft destroyed during the day's operations. German losses exceeded 40 fighters. That exchange rate spelled doom. The Thunderbolts had proven they could defeat German fighters in every type of engagement, from dogfights in the weeds to high-altitude interceptions. As darkness fell, German night fighters attempted to attack the invasion fleet. The 8th Air Force had equipped several Thunderbolt squadrons with experimental radar for nighttime interception. The new propellers proved essential for maintaining position with these radar-equipped aircraft during complex night maneuvers. The improved climb performance allowed the Thunderbolts to position themselves above German night fighters and attack with that same altitude advantage German pilots had once enjoyed exclusively. Frank Caldwell received the first reports of the air battles at the Hamilton Standard factory in Connecticut. His team was working around the clock to keep producing paddle blade propellers. The success over Normandy vindicated everything he had envisioned. The radical propeller design had transformed American air power from a defensive struggle barely capable of protecting bombers into an offensive weapon that could dominate European skies completely. The implications stretched far beyond individual air battles. Allied air superiority over the invasion beaches meant ground forces could advance inland without facing constant German air attacks that had plagued earlier amphibious operations. The Luftwaffe could no longer contest Allied air operations effectively. German ground forces would face the rest of the war without meaningful air support, a situation that would prove decisive in the campaign for Western Europe. German aircraft designers studying captured paddle blade propellers in late June reached conclusions that chilled them. These propeller modifications represented advances in metallurgy, precision manufacturing, and aerodynamic design that German industry simply could not match with available resources. More disturbing was understanding that Americans had solved the fundamental problem of converting high horsepower into effective thrust. This breakthrough would provide lasting advantages in any future aircraft designs. As June ended and Allied forces consolidated positions in Normandy, the strategic impact became impossible to deny. The paddle blade propeller had not merely improved the Thunderbolt's performance, it had fundamentally altered the balance of air power over Europe. German pilots, who had once hunted American fighters, now found themselves the hunted, unable to escape Thunderbolts that climbed faster, flew higher, and fought more effectively than any German aircraft could match. The transformation was absolute and irreversible. The aircraft, once dismissed as a flying milk bottle, had become the terror of European skies. The engineer who designed those 13 feet of revolutionary propeller blades had changed the entire air war over Europe. The Luftwaffe would never again possess the tactical advantages that had made German fighters masters of European skies during the war's early years. When the war ended on May 8, 1945, Frank Caldwell stood in his Hamilton Standard office reviewing production reports. Over 12,000 paddle blade propellers had rolled off American assembly lines since that first experimental installation in October 1943. Each one represented a small miracle of precision manufacturing that had required retooling entire factories and retraining thousands of workers to build something everyone said was impossible. Colonel Francis Gabreski's final mission report provided the human dimension behind those production statistics. His 56th Fighter Group had flown over 15,000 combat sorties with paddle blade-equipped Thunderbolts. They had claimed 438 enemy aircraft destroyed while losing only 47 Thunderbolts in air-to-air combat. The exchange ratio exceeded 9-to-1 in favor of American fighters. Such performance would have been impossible without the climb rate and altitude capability Caldwell's propellers had provided. Before the paddle blade modifications, Thunderbolt units typically achieved 3-to-1 exchange ratios against German fighters. Respectable but not decisive in a war of attrition. After the modifications, that ratio had tripled. Every air engagement became a lopsided victory for American forces, hastening the collapse of German air resistance over Europe. Major Wilhelm Speck's final intelligence assessment from captured Luftwaffe files acknowledged American achievement of a technological breakthrough of decisive importance. German engineers attempted to develop similar improvements for their own fighters, but shortages of critical materials and manufacturing capacity made meaningful progress impossible. The paddle blade propeller remained exclusively American throughout the war's final year. The human cost of that advantage was measured in American pilots who returned home alive instead of joining casualty lists growing longer each month. Lieutenant Robert Johnson, who scored his first victory with a paddle blade Thunderbolt over Berlin in March 1944, flew his final combat mission with 28 confirmed kills and 0 losses to enemy fighters. His survival multiplied across hundreds of American pilots represented the most meaningful measure of Caldwell's engineering success. The paddle blade's impact extended beyond individual pilot survival to reshape the entire strategic balance. German bomber production ceased by early 1945, not because factories were destroyed, but because the Luftwaffe could no longer provide fighter escorts capable of protecting bombers from American fighters. The paddle blade-equipped Thunderbolts had made German air operations so costly that the Reich's aviation industry abandoned bomber development in favor of desperate attempts to build defensive fighters. Caldwell's unconventional thinking spawned an entire generation of American aircraft innovations. The North American P-51 Mustang incorporated similar paddle blade technology in its final variants. The Republic P-47N model that began production just as the war ended carried his innovations forward. American aircraft designers had learned that brute force approaches backed by superior manufacturing capability and material science could solve seemingly impossible engineering problems. Frank Caldwell received personal recognition through a Presidential Medal for Merit, presented by Harry Truman in a White House ceremony on June 15, 1945. The citation praised his revolutionary propeller design, materially contributing to Allied air superiority over Europe. Caldwell understood that the real victory belonged to thousands of American pilots who had flown his propellers into combat and returned safely home. Post-war analysis of German aircraft development revealed how completely the paddle blade revolution had disrupted enemy planning. Captured documents showed German designers had abandoned several promising fighter projects in late 1944 because they could not match the climb performance American fighters demonstrated in combat. The psychological impact of facing thunderbolts that outclimbed German fighters had proven as devastating as the tactical advantages themselves. The manufacturing legacy of the paddle blade program extended far beyond military aviation. American factories developed precision casting and machining techniques for propeller production that found applications throughout post-war industry. The metallurgical advances required for the paddle blade's strength and weight specifications contributed to improvements in automotive engines, industrial machinery, and eventually commercial aviation. Caldwell's wartime innovation had accelerated American manufacturing capability by years. Military planners preparing for potential future conflicts learned crucial lessons from the paddle blade's success. The program had demonstrated that technological superiority could be achieved not just through revolutionary new designs, but through innovative applications of existing technology. American aircraft engines had always been powerful. The paddle blade propellers simply found a way to use that power more effectively than anyone had imagined possible. Production lines that had manufactured paddle blade propellers began retooling for civilian aircraft applications by summer's end. The same broad blade technology that gave Thunderbolts their devastating climb rate was being adapted for transport aircraft and commercial airliners. Caldwell's wartime innovation was transforming into peacetime prosperity, promising to revolutionize civilian aviation just as completely as it had dominated military skies. The final measure of paddle blade success came from an unexpected source. Captured German pilot interviews conducted after the war's end consistently identified the appearance of modified American fighters as the turning point. When German air superiority became untenable, Major Klaus Mietuscher, who survived over 200 combat missions, described the paddle blade Thunderbolts simply: "They were the aircraft that ended our war in the air." Frank Caldwell closed his final wartime engineering report with characteristic understatement, noting that the paddle blade propeller had exceeded design expectations in operational service. Behind that modest language lay the reality of an engineering revolution that transformed American air power from defensive necessity to overwhelming dominance. The radical propeller idea that colleagues had dismissed as impractical proved that sometimes the most unconventional thinking produced the most decisive results. The war was over, but Caldwell's revolution in propeller design would continue shaping aviation for decades. The principles he established would guide American aerospace development through the jet age and beyond. Efficiency mattered less than effectiveness. Conventional wisdom deserved constant challenge. Radical solutions often succeeded where incremental improvements failed. 13 feet of paddle-shaped steel had changed far more than the performance of a single fighter aircraft. It had demonstrated the transformative power of engineering courage in the face of impossible challenges.